In this video, we are going to restore one of the oldest projects I have made for my third year of undergrad school. Previously, I had made a tutorial on animation using a 3D model of the same project. Its link is given in the description. While making this device, care had taken to make it more robust. This device can be used for measuring 9 physical quantities: RPM of rotating object, strain on a metallic objects, length using a roller, distance using ultrasonic sensor, angle of surface, 3-axis vibrations, temperature, magnetic flux and voltage. I usually don't reuse the components once used in any project, so most of them require a minor repair to get it back on track. Let's see, what are the problems we need to face while repairing this project? This is the mouse scroll. Its shaft is broken, so we need to replace it. Now let's open the casing. This is 2-level PCB. I made it like this to make a compact device. This encoder wire is broken. This battery wire is also broken. This is a homemade PCB, there is no solder mask, so upper layer of copper tracks is oxidized, but there is no discontinuity in any copper track. Now let's connect the battery to see whether it is turning on or not. You can see the blinking LED on the Bluetooth module. Now let's connect the device to our mobile app. We got data only for a second and then the device got disconnected. Let's debug this problem. There might be some discontinuity in the data lines of Bluetooth. Let's remove this glue. Yes, as expected, this data wire is broken. We need to solder it. Now I am soldering a broken wire of the rotary encoder. Now, we need to replace this scroll, but there are some obstacles in its path, so we are directly breaking it. Now we can remove it easily. We are going to use this scroll for our device. Let's open this mouse and take it out. We got the scroll wheel. Hope both scroll wheels are of the same size. Unfortunately, they are not. So we need to remove some material from the scroll as well as from our casing. After filing, the scroll wheel is well fitted in the casing. Now we need to improve the aesthetics of our device. So we are now stripping off these adhesive tape. After removing adhesive tape, there is still a sticky layer of adhesive, which cannot be washed by using water. To wash this out, we need some acetone and cotton. Sticky layer of adhesive is washed out. Now let's assemble the casing. This is a power switch. We need some square-shaped acrylic sheet for these buttons. As I planned this video 3 months ago, I put some buttons in my last acrylic cutting job. After fitting, buttons will look like this. On the backside, I used a flat rubber which can be bought from any lady's shopee. Now our device is ready to test. So let's assemble and test it. I am pressing the power button. Then selecting the Bluetooth device. First, we will measure the angle. And still we are not getting the data. I think again there is some fault. Let's debug it. After 2 hours of debugging, I found that some IC leads were not connected to the IC base. Let's take the IC out and see what the problem is. You can see there is some black layer on the leads. It's because this IC was not taken out off the IC base for the last 5 to 6 years. I am removing this layer using a sharp cutter. Now again, our device is ready to test. Hope this time everything works well. Let's see the angle first. Great, it's working. It's not showing the correct angle because 6 years ago, I did not know the Kalman filter used for calculating the angle. Now, I am checking the distance sensor. We can see the distance of the wall in centimeters from our device. Let's check the vibration. This graph shows acceleration on 3 axes. Now, I am moving device in the z-axis. Now, in the y-axis. And now, in the x-axis. Now we are testing the temperature sensor, and it is showing 29 degrees Celsius. Now we are checking the magnetic flux sensor. For one side of the magnet, it is showing extreme negative, and for the other side, it is showing extreme positive. Unit of magnetic flux is Gauss. Now we are going to check the RPM. This is the RPM sensor. There are 7 blades in this fan, so to get the correct value of RPM, we need to divide by 7 to the RPM shown by our device. Now let's start the fan. It is showing nearly 10,000, so actual RPM is nearly 1400. Now we are checking the voltage. For that, we are going to measure the supply voltage of our sensors. It is showing nearly 4.2 volt. Now we are measuring the length of the tile using the scroll, which is nearly 60 centimeter. Last feature of our device is strain measurement. For testing, I attached a strain gauge on a metal scale. It is showing some offset value. I am beating the scale in both directions, and that is reflected in the graph. So, we have tested all 9 features of this device. Hope it will work for the next 5 years. Please let me know your feedback in the comments section below, and subscribe to Electro Creativity.